Hello, Assalamu alaikum. Good morning, everyone. It's me, Dr. Irfan Ahmed, and This is my first lecture about the statistics, like what is statistics and what is biostatistics and what is the basic fundamentals of statistics. Okay, what today we will discuss about this. The statistics is not just only the terms that can be used in the education or for the students only. It is like we are also surrounded by the statistical theories and statistical parameters. For example, when we turn on the television and we want to see about the weather or about the winning of the election about something or the winning of the lottery, and even if someone do a lottery. So this is all about the statistics. It's based on the probability theory. Or the second thing is like if you want to see the true or the is there a positive or negative effects of parentage or the association of parents with children's or relationship of patient and children's. These are also based on the statistics. The basic theory behind this is correlation and regression. Or the third example is like demographic consensus. Like for example, if you want to see about the any in a specific geographical area about any about if you want to study the people, their specific characteristics about one specific geographical area, it is also about the follow the parameters of statistics. Or we want to do a disease survey, the prevalence of the disease, incidence of a disease. It is also based on all the statistics about the stump, for example, the study design or the sampling, so on. The fourth example is the estimate the effectiveness of drug. Like in the medicine, for example, if someone discover new drugs and they want to find out that whether this drug is good or not, so he has to do the RCT, which is a type of study which is done in the based on the statistics. So these were all about the definitions or the examples from the common from the community that and now the scientific definitions of the statistics is like the science dealing with the collection, analysis, interpretations, and presentation of the masses of the data. So it's all thing based on these four steps. Like you have to collect the data, you have to do survey and then collect a data. And how we collect the data we will discuss later. And then within this presentation we have to collect the data. When we collect the data, then what to do with the data? We have to analyze it. It's not analyze just to see and then verbally calculated, or that yes, this number of patients and this is not, but we have to analyze them properly by using a specialized software in the statistics or the specialized formulas. And the old time it was very difficult because the formulas of statistics was very complicated and it's not very easy to understand. But now in the modern times, in the recent year, it's very easy because of the invention of the SPSS software. It's do everything for you. When you have to put just you have to put all your collected data inside the software in a proper way. And then the third step is interpretation. When you analyze the data, then you have to interpret the data. Interpretation is like to go make for any conclusion, like what is my results, and it's compare it with already existent literature, existence to your or somehow exist some similar to your study or somehow similar to your study. And the fourth step is the final and the most important step. That's all the statistic around on this the fourth statement, the presentation of the data. If you don't present it, then it is completely waste of the time and the waste of money, waste of effort. Because the main purpose of the statistics or all this process is to convey all the information that you derive. So this definition is from the Webster International Dictionary. The second is the Dictionary of Epidemiology, which states that the science and the art of dealing with variation in the data through collection, classification, analysis, and such a way to obtain reliable result. It's also contains the same domains like the collection. Classification is just the second, because this is like the broader term. If you collect the data from a large sample size, for example, for a whole nation or for a whole country, then you have to classify it according to the nation or according to the race, according to the religion. So collect the data and then classify them, classify them and then analyze. When you analyze them each individually, and then you have to compare, cross comparison can be done. For example, if you want to see the physical activities and the Muslims and the Christians, so you have to collect the data from Muslims and the Christian, and then you have to classify them according to the domain for the Muslim, and then for the second is for the Christian. And then you have to analyze them. Analysis in this case, it can be analyzed in many ways. Intergroup comparison can also be done in the analysis. Within the Muslim, there is further sub-tribes, and in the Christianity, there is also further sub-tribe. So you can also analyze them within the group or with cross comparison, compare Muslim data with the Christian, and then is such a way as to obtain a reliable result. So you have to analyze them in proper manner. Okay, the second thing is like statistics. What is the statistical? The scientific activity of data collection, same collection, sorting, analysis, interferences. Interference mean to go for some conclusion or judgment. And judgment, the general principle and methods, it's the key points of statistics, like to investigate and analyze the objective phenomena. You have to, and you have to investigate and analyze the phenomena in the statistics. Statistics is not only a discipline in its own right, but it is also a fundamental tool for investigation in all field of science. It is not the separate field. It is actually the root, or not, it can be root, but it can actually link with every field. If there is no statistic, for example, in the medicine, then it might not be possible to invent new drugs and legalize by, for example, FDA, because FDA approval need it safety, and for the safety you have to follow the statistics rules and do the RCTs to find out the safety of these drugs, or and so on. So it's the main fundamental tools for investigation in all field of sciences. Now let's talk about the medical statistics. What is medical statistics? If the name shows that the statistics that are done in the medical field, they are called medical statistics. But let's come to the theory. What this says: to study trends, problems, and phenomena in biology, medical, hygiene sciences, detect the causality and association, reveal the rules and laws using theories and methods of statistics, probability theory and mathematical theories. I think you will know about this, not very difficult words. Like the causality and association mean the cause and effect. Like, for example, in the medicine, if you find a new drug, you have to find the effect of this drug on the body and also the side effects, or you can find out the effect of this drug compared to the already existent drug in the market. So if this drug is better than this drug, so you have to apply, you have to raise awareness about these drugs by publication, by publish your studies in the different journals. Okay, medical statistic method are used, number one, to collect data to appropriate ways. It's not like just you go there and ask some question from one person and some question from other, but you have to follow an appropriate methods and use appropriate tools. Like, for example, if you want to know about the physics, for example, if you want to know the quality of life of for example, of the cardiac patient, so you, for that reason, you have to follow a specific tools that are approved on this and that are standardized. Okay, for example, for that reason, you have to follow the WHO quality of life and index, or SF36 quality of life index. So you have to follow the proper standardized methods. Okay, or any instrument, the standardized instrument or standardized instrument or any machines. And for example, if you want to do get analysis or motion analysis, so you have to do the 3D motion analysis system, not like just you ask the patient to run and you just see them. It's not the same easy as it is. The second one is to describe characteristics and distribution of the data, to data reductions, indicator choosing and calculation, and result interpretations. It is the same like you have to the characteristic and distribution of the data to describe, like to find the sample size, then you have to find the population, then you have to find the sample size data reduction, and indicator choosing is like the same, you have to follow the specific approach, specific tools you have to choose. And then calculation, mean analysis, and result interpretation is to find the conclusion, reach to the conclusion. And then the third one is statistical analysis and make conclusion, make statistical interference on the difference or association among variable, detect causal factors, mean cause and effect, assess effectiveness, help to make decision. The same thing that I discussed earlier. Now the next slide is steps of statistical work. Like as I talked earlier that statistical work should be done in a systematic way. So what are the systematic way? These 4 steps should be followed. So these are the systematic ways. Number 1 is design of the study. The second step is data collection. The third one is data sorting. And the fourth one is data analysis. So what is design of the study? Design, there is 2 steps in the design. The first one is the professional design. The professional design include you have to find the topic, then set a hypothesis. If you find a topic, for example, if you want to find out the effect of breathing pattern disorder on quality of life, okay, so the set hypothesis should be like the patient with breathing pattern disorder have poor quality of life. Okay, this is your hypothesis. Select subject. Subject, you have to find from whom I collect the data. What is my subject? So my subject is the patient with breathing pattern disorder. Sorry. Okay, the fourth step is determine outcome measure. So how can I approach this patient and how can I collect the data from this? So you have to determine the outcome measure. Which outcome measure should I use? For this, you have to search the literature and find out the best outcome measure that can be used for the patient with breathing pattern disorder to find out their quality of life. So for that reason, for the outcome measure tool selection, there is several things you have to keep in mind. For example, you have to check for your patients, your population. The third thing is like the disease group. Which disease group? For example, a population mean you are targeting elderly, adolescents, or the children's. The second thing is you have to choose about the disease. Which disease group are you targeting? In my case is, for example, if I choosing elderly and I am targeting the breathing pattern disorder, so for that reason I have to choose WHO quality of life index, because it is standardized and it has the in validity and reliability, good validity and reliability for elderly patients. Okay, techniques and tools, like techniques, which techniques you will using. Okay, so like for example, in the techniques you will discuss this, and then in the design in the statistical design. So the statistical design include making the proposal. When you finalize all your first thing, actually this first professional design come in your introduction section. The statistical design, this come in your methodology section, somehow in the methodology section. Okay, like make a proposal, determine sampling methods, like which sampling method should I use. There are so many sampling techniques like random sampling or non-random sampling or convenient sampling anyway. So you have to find out based on your study, on your sample. Then you have to find the sample size calculation. There is different software that is available like GPower, open API, or so on. So it is available freely on the Google. So you have to find the sample size from them. Allocation methods, allocation, you have to allocate the patient into different groups. So you have to design, and this steps you have to find out this. And statistical analysis method, which statistical test will you use for this? For example, if you are doing the cross-section studies, so you have to do this independent t-test or some things. If the data is actually, statistical tests depend on your sorry, statistical analysis method depend on the actually your normality. If the data is normally distributed, and then you have to follow the parametric tests. If you have not, then you have to follow non-parametric statistics or tests. So this will be discussed in our later classes. Just go through in this slide. And the design of the study, we have actually two main design. This is actually the steps that are involved in the design of the study. When you are choosing these two steps, these two study, you have to follow on these two points. So observation study is the cross section. The examples of observation study is like you just observe the patients and just take observation study is the type of study you just observe the patient from the outside, and you are not doing any interference to the patient. You are not doing any intervention. You just see the patient and take the data. Only that. But the example of this is cross-section study. First example is cross-section study. We will discuss this and our study design and type of studies design in our next presentation. The second is case control study, and the third one is cohort study. All these studies are you have to just observe the patient and collect the data. You have nothing to do with the patient, no intervention, only just take the data from the patients and then analyze them. And the experimental study or the trial study is like about there are further some examples like for like defined to when we define experimental study is a type of study when you have to interfere the study. When the researcher interfere the patient, you have to interfere, you have to do some drugs or do some exercises to the patient and then see the effect before this and before the introducing of this drug or the exercise. Take the data before, and then after some time doing this exercise or taking these drugs, taking the data again from these patients and then compare both, that whether the patient improve or not improve or the same. So this is the experimental study. The example is on laboratory research or the research that is done on inside the laboratory. The second one is randomized control trial that is done on the public directly, and the clinical control trial. This is also the type of experimental study. The second step is data collection. When you decide your study design, then you have to go for the data collection. The data collection is two type. You do one is the routine and the one is one-time data collection. The routine data collection is like the way that you collect data with routinely or with some continuously with some specific period of time. For example, the teacher, mostly in the good schools, the teacher do a progress report every day for their students to check whether they improve or they're not. So this is the routine data collection. Okay. And the second okay, and the one time data collection is like in sometime the schools once in a time they collect, or even the education ministry, they take data from the school only one time in a year. So this is one time data collection. So when you collect the data routinely with a specific period of time or daily, this is called routine data collection. Some researches include follow the routine data collection, and some researches are on one-time data collection. Data collection should be there. We have to follow these points when you are data collection. The data should be accurate. There should be no ambiguity. It should be appropriately timely manner. It's not like you collect data from one patient today, and the second person you collect data from 1 week, and the third patient you collect data from 4 days after 4 days. So not, it should be collect timely. When you collect data from one patient, you have to collect all data from all patients at the same time. Okay, so it is still should be timely manners. It should be integrity and with regulations. Okay, with proper rules, regulation, follow the statistical rules. And the data sorting is like systematized and simplified. Okay, Actually you have to sorting mean actually you have to arrange the data into the group by quality and quantity. And the quality mean like the patient with the for example male and female. Male is the quality, like this is the characters. So male is divide giving one divide into one column, and the female is given to the other columns. Okay, so you can be divide the sorting can be done in any manners. Either it can be on the basis of quality, like I just told you that, like it's for example male or female, or for example it should be a quantity. For example, the patient with a higher score should be categorized into one group, or the patient with a lower score should be categorized into the other. Okay, an example, high age group should be categorized into one, and the low age group should be categorized into other. So this is the data sorting can be done in a variety of ways. Okay, for example, if you want to find the data or take the data about weights, so weight can be categorized into normal weight, pre obesity, overweight, pre obesity, and obesity. So you can categorize them on the qualities. Okay, or if you want to qualify in the basis of kilo of the kg, so you have to go them the weight according to above 50 kg, above 100 kg, between 50 and 100, between 50 and 150. So this is the grouping sorting. The fourth step is data analysis. Data analysis is the two steps that you have to keep in mind: statistical description to describe and calculate the quantitative characteristics and distribution regularities of original data using appropriate statistical table, charts, and indicators. Like statistical descriptions mean like you have to present your data in appropriate ways, an appropriate way, by making a tables, charts, or indicators like pie charts or graphs or something. So you have to describe them so that it can be easily accessed, easily understandable. And statistical interferences conclusion is to interfere the population parameters by sample statistics, including parametric estimates and hypothesis testing. These actually points will be discussed in the later videos. You have to just understand for now little bit. So now this is the small question from you guys. I want you to answer this. Is what which in all of these four type of steps, what do you think, which one is the major steps among these four steps? Number one is study design or collection of data, data sorting, and data analysis. Okay, to answer this is like because every step depend on the design of the study. When you design your study, for example, if you design the cross-section study, then you have to collect the data accordingly and sorting them accordingly, analyzing them accordingly, because there are some tests that are only specific for cross-section studies, some are only for RCTs. So you can't do the analysis, sorting, or there are some collection methods differently for every studies. So design of the study is the most important step around which all your studies depend. So first, that the main thing you have to find out which study design am I doing. Now, type of statistical data that we talk about so much time, that statistics data and data collection and so on data. So what is data? And data is actually what we call it variable. Okay, variable is like the characteristics of research objects. Okay, and characteristics like for example male is the characteristics. Okay, or we can say weight or height. So this is the characteristics of research objects. This is called value. Okay, and the value sorry, variable, and variable value, the value of such variable is called variable value. For example, if I say that height, so the weight value of height is called variable, and value of height is called variable value. For example, he is 6 feet, so 6 feet is variable value, which is also called data. Now, type of the data or type of variables, there are two type of variable mainly. Okay, the one is numerical and the other one is categorical. Okay, numerical data is Numerical data is also called qualitative data. It is actually related to the quantitative, it's related to the quantities, like it's countable. And categorical is more related to the like qualitative data. Okay, a special qualitative data is also called rank or ordinal variable. Now, nominal or quantitative data, to investigate and measure some indicator of study object and obtain the data. Okay, characteristics of the nominal data is, these characters should be keep in mind when you look the data and you want to find out whether it is nominal or it is categorical. So the first one is the level is indicated by the level of measure value. Okay, it's the level, like how is the level mean its variable value. It's indicated by measure value. For example, if say height, so the level of height is indicated by value, not by their characters. Okay, like if I say male, so male have no value. We identify male on the basis of their quality, not on the basis of their value. So male is not nominal value, but level height is a nominal value because it has a true value, measure value, usually with units. For example, height, so it is male is, for example, height is, for example, 6 feet, so feet is unit. Sometimes they don't have units, and includes continuous and discrete. It can be further, like nominal, it can be further divided into continuous or discrete. Continuous is like that come with points. For example, the height is 6 feet and 2 inches, or weight is 10 kg plus 10 kg and 6 gram. So this is like the continuous. And discrete is those that come with a true value, not with points. Okay, for example, if I say blood pressure, so it should be 120 or 125 or 140. It can't be 120.5 or 120.5 into 80.5. No, it's 120 by 80. It is fixed value. Okay, systolic by diastolic. Or red blood cell count, red blood cell should be, for example, 6 lakh or 3 lakh or 4 lakh. It can't be 3 lakh 0.5 or something. Okay, so this is the discrete and continuous. This is a form of numerical data. Now come to the categorical or qualitative data. It is the categorical data is like the data that is represented by, not by the value but by the qualities. Firstly categorize the study individual into different groups by some characteristics, qualities, and then calculate the number of each group. Okay, characters. Now how can, these are the characters, different sorts among groups, either or type of observation. Okay, different types among groups, like for example, we can say gender, or we can say married or unmarried. It is unordered. If I write unmarried first and married later, or married first and unmarried later, it doesn't affect overall the quality of the studies or the data. Without any units, I can't say that I am male meter, male kg. No, male only male, or I am married only married, no unit. Example is like gender, male female, yeah, dichotomous, or is dichotomous data. Or a data type is a blood type, sorry, is A B O A B. Okay, career is farmer, or occupation is farmer, worker, teacher, or engineer. These are all categorized categorical data. Now the ordinal or rank data, if there are more than 2 categories of group, and they may be possibly ordered in some way. Sorry. For example, if this is just it can be some form of categorical data, but if the type of categorical data on which the order of the data affect the result, so that type of data is called order or rank data. Characters, order or semi-quantitative data. Ordinal, gradually increase or decrease in a group. For example, cancer stages, early stage, middle stage, and later stage. Okay, So every stage have different characteristics. So every stage represent a specific group of people. Okay, like treatment outcomes, cure, relief, ineffective, or dead. Every stage represent different domain. So this time of or if we can't categorize them into ordinal because there are specific order inside this this data, because we can't say early, late, middle. No, it should be early, then middle, then late. Okay. Then urine proteins or Helicobacter pylori. Pylori is H. pylori. It's either maybe positive or negative, positive, positive, or positive, negative. Okay. So this is type of ordinal. It can be ordered. Okay. Now this is the last slide, and this is the main judgment criteria. According to these two criteria, you have to define your data, whether it is nominal or it is nominal or it is categorical. The first, look into this carefully, whether categorize objects by characteristics. The first is whether the object or the variable is categorized by characteristics or not. Okay. The second one, whether each observed individual has an exact measured value. Okay. If each have their exact measured value, and it can be categorized also. So if both are yes, it means it is nominal or quantitative data. Okay. For example, if I say height, so height can be categorized, for example, small height, medium height, and higher height. But it has a specific value of each value. For example, middle height, I give the patient with, if they have uh, small give to those patients or those individuals if they have the height around 3 to 4 feet, or middle from 4 to 5, and higher is from 6 to 8 feet. So everyone, each observation have the exact measure value, and they can be also categorized. Okay, so if both are, so it means it is nominal. If no for both, they can't whether categorize object by characteristics. They are not categorized by characteristics but by qualities. Or if only one is true, it means it is not non-nominal. Or if both are no, it means it is categorical. Let's come to the final slides. It is only just the table. This is the age, so we have to do this like it is just of true values, exactly the values without points, so it means it's a nominal and discrete. Height 16.5, height, it can be it is nominal, but it cannot be discrete, it is continuous. Weight, it is also continuous. Hospital days, it is also discrete, nominal, discrete. Now cancer, it is stages, unemployment, unemployed teacher, so it is qualitative data or categorical. Education, this is also qualitative or what we call it is categorical. That is also categorical, and this is categorical. This is quantitative and this is qualitative data. So thank you so much for today. It's the final, it's our first meeting. I hope you enjoy it and you learn a lot about it. And now see you in the next meeting, and bye bye for this meeting. Bye bye for now.